Hello and welcome back. Now we'll really start getting into the tables and write some code. Previously, what we have seen are these tables. We looked at what columns are there, what type of data is in each of these columns, and then we looked at this particular sort of compilation of all the column names that we can easily look at to join the tables. Now what we can do is start looking at the values in each of these tables. So let's say if we want to look at this table, what we can do is can create a new tab like here, and then if you click on this and say copy ID, we can get the path for that, and then we can write our code. So the way we are going to write this is we'll use the select statement, select star, and then from. And here we want to use this angled quotes, and then paste the path that we copied, and then again close it with another angle quotes, and then we can limit this to 10, and then place a semicolon either there or below it. Now when we run this, we should see down below in the output all the rows, 10 rows, and all the columns. So that's the borough code, that's the borough name, we have the borough area, a length, and geometry. I think that those are all the columns we have. Now from this, what we can find is how many borough names are there in this particular data set, in this table. And for that, what we can do is we'll say select distinct, and we'll look at just the borough name, and we'll see how many names are there. So we'll just say distinct borough name, and this time I'm going to comment out the limit part and then run this query, and hopefully we should see an output. So we have 5 different borough names. That's what we have here. And at the same time, what I think we should be doing is looking at the map. And for that, what we can do is we can type in here and New York subway metro map, and hopefully we should navigate that website that we looked at earlier. And here is the New York City subway map. And what we looked at was different boroughs. So Brooklyn, Staten Island, Bronx, Manhattan, and Queens. And if we go down this map, we see that here we have Manhattan, here we have Queens, and then here is Brooklyn, that's Staten Island, and we still need one more. We want to look at Bronx, so let's see where it is. Brooklyn and Queens. So, and there is Bronx. Okay. So with all of these in mind, now we can start thinking. Well, we now have a mental picture of where each of these boroughs are located, and accordingly, then we can start framing our questions as well. So it's as you can see, if we so Staten Island is there's the Liberty Island is there, and then Staten Island Ferry. So that's what we have. So based on this, we see that there are several routes, there are several tracks that go to Brooklyn, as we can see here. There are several that go to Queens side, and that's right here, and several that go to the Bronx area. So Manhattan seems to be at the sort of the main intersection where all of these go through. While we have some connections that go from Brooklyn directly to Queens, but if we want to go to Bronx, right here, from this map at least, it looks like the metro that we have to take would have to go through Manhattan. There's no other way to get there. And likewise, if you are trying to get to the Staten Island, then it would have to be from Manhattan as well. So there's from somewhere here. So I'm not sure if the train goes to Staten Island or we go by ferry to the island and then take the train. Well, that's what we have with this data set. Again, we can go back and look at the entire data set. So let's comment that out again. Look at the 10 rows of the data set. And right here, we have the borough code. So each borough should have a separate codes. I'm wondering if a borough has more than 2 codes, and if you want to find that out, what we can do is we can look at the we can group it. So let's do that. What I'll do now is copy this. We'll try to write different queries on separate lines. So if you want to rerun a particular query, we can go back up and run that. So let's remove this. And in these simple queries, it's possible to write it in live session like this. But as the queries get more complex, I'll probably write them ahead of time and then just put them on the screen and walk through the code. Select distinct, and what we are looking at, what we want to look at is the borough code and borough code and borough name. Now we can run this part, and in here now we can see that each borough name has a different code, starting with Manhattan as 1, then we have Bronx at number 2, then we have Staten Island number 5. So what I would suggest is, if we if when we look at this map, I'm going to zoom out a little bit. So this is number 1, Manhattan is number 1, then Bronx is number 2, so we go up, that's number 2. Then number 3 is Brooklyn, so we come down all the way here, that's number 3. Staten Island, no, after that Queens is number 4, so that's number 4 right here. And finally we have Staten Island, which is number 5. That's how this is distributed. And if we want to look at it later on, we can always come back and quickly look in this table to see what borough code refers to what borough name. All right. With that, then I think we have what we have sort of an idea of how many boroughs are there and other details from this table. Let's see if there is anything. The other is the latitude, longitude. At the moment, we do not need this. Maybe if we try to plot these results, then maybe it will be helpful. But for now, we are good with that. Next, we'll look at the routes table. Again, for routes, what we can do is we can click on the 3 dots, and then go here, click on copy ID. I'm going to create another notepad or tab, then copy this select code right from there, paste it here, and again let me copy this again because I just copied that lines of code. So copy ID and replace this particular path to the table by this path, and again we can run this line of code to see what we get. All right, so we have the route ID, route short name, long name, and then we have the route description, route type, route type. So I'm not entirely sure what the type is referring to. So if you look in this table, in this some sort of chart we have, when we look at the routes table, that's yep, that's the routes table, and this is the table we are looking at. we have route type. So I'm not exactly sure what that is going to be, and I don't see any other information here. So trip ID, trip design. Maybe we'll find something as we continue to explore this data set. Here we have route 1, route 2, route 3, route 4 to route 11, but I'm not sure what the route type is going to be. If we look at the maps, let's see what route ID we have here. We have GSCER7. What we can do, as we did before, we can look at the distinct route IDs and uh, compare those values with what's on the map. Distinct route ID, and in this case we do not need the limit because we want to see all the route IDs, and hopefully we should see them here. As you can see, there are several of these, around 30. So we have around 30 route IDs. Yep, 30. And let's look at couple few, top few of these. There is GSCEWN. So if you come down on this map, and if we scroll down a little bit, go to this side, here what is the map depicts typical weekday service, weekends, and this is weekdays, late nights. So these must be the routes. So what we have is GS. Let's see if we have a GS in here. We do not see a GS. How about CEWNR? So we have C, E, W, N, and R. So we have all of those. And again, if we keep going down, there is DB23AQ. So do we have the 23 is there, A is there, Q is there, DB is also there. So I think all of these are there. Overall, how many different routes do we have? A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 are listed here, and 15 of these, and there may be other services as well. So if we look at the other maps, maybe we would be able to find those there. So let's click on this, open this here, and that's one map. And the second map is a large type subway map. Wonder what that one is. Okay, so this should have all of the routes, looks like. But still, the one that we are looking for, GS, the very first one, it's not there in that map either. Maybe it's in this map. No, it's not there. So this is late night service. So I'm wondering if that particular service is available at night. This is no. All right. We have all of these. Okay. So at least we know what these route IDs are referring to. The route IDs are essentially the routes that are in the maps that we just saw. And here are the short names. Oh, so the GS is probably the S in the map. The Rockaway Park shuttle. Maybe, or these shuttles, those could be the S, those could be the GS here. EW to and so on. So that's good. Next thing we can look at is the long name. Long name is 42nd Street Shuttle, and exactly, awesome. So as you can see, that is right here, 42nd Street Shuttle, and that's what this is referring to. So the route ID that we are seeing on the map are actually the short names of the route ID. So this is what we would find on the maps. And these are the names given to each of these routes. For example, C is 8th Avenue local. So if you go and look at C, that's the 8th Avenue local. So that is nice. We are now are trying to really understand how the maps can be read. And here we have this information which says trains operate between 168th Street, Manhattan, and the Euclid Avenue, Brooklyn. Okay, so that's for the route C. What we can do then is look at route C. It's in blue color, and we just read that it's from Manhattan to Brooklyn. So let's find out the route C. Here it is, the blue line, and the blue line, it in Brooklyn. Where is Brooklyn? Right here. And in Brooklyn, it should have a last stop in Brooklyn, which is uh, which is uh, which should be this one, the Euclid Avenue in Brooklyn. So can we find that? Yeah, here we have the far beach, and then we have, so that's the beach, and here we have the 111th Street. So that's A. Here, right here. So this is the Euclid Avenue. As you can see, that's where the route C starts, and what we are looking here, that was route A. Although it's the same blue color, what we are looking at, interested in, is the route C. So that's where we start, and then we can go all the way through here, Franklin Avenue, all the way through here, across the river here, and then into Manhattan. And inside of Manhattan, we're still going, that's C, and we can keep going until we touch this station. I think this is the station, 168th Street, Manhattan. Let's see where 168th Street is. Right here. Right here. So what this particular route, the way this route is going is, we start right here, and then we go all the way up to here. So that's like a L shape, and that's what this information is giving us, is from where does it start, where does it end, and a route type. This is route type 1. Again, from the information that we have, I'm still not sure what that one is referring to, unless it is mentioned somewhere. Yeah, so this is 6 a. This goes from 6 a.m. to 11 p.m. So that's the morning hours. Maybe a different route type could be referring to maybe the late night hours. Let's find out how many route types are there. So what I'll do is simply copy this and paste it here, and then look at the route type. So route type, and run just this part, because we are interested in just finding how many different route types. So there's just 2 of these, and so I'm guessing that it may have to do with the morning service and the late night service, because there is a separate map for the daytime, and then this is a separate map for the nighttime. And all the daytime could be that they are route 1, the type 1, and the others are type 2. But we won't know for sure until we see the time data. And in this, we do not have the time. So later on, when we join the tables, hopefully we would get an idea of what the timings are for each of these routes. For now, I think we understand what the route ID is, what the route short name refers to, what the route long name is. That's essentially the station name. A short name is what is used on the maps. That's the description. It tells where the route starts, where it ends, and what time the run is. And then this is the route type. What we could do is uh, when we are looking at the route, this data, we can put a filter. We can say where a route type is equal to 2, just to check what is the timing for that route. Let's see if we can get that information. Or route type. Yep. Run this. You see that exclamation mark, it means something is wrong. And I'm guessing the reason is because if we look at the data type for the routes, if we look, we don't have the data type there, but if we click on this and let's say open in new tab and look at the route ID, although they are numbers, the data type is a string, and that's what's causing the error. So what we have to do here is put these two in quotation marks and now run this so that it will match. And so with route ID, we do not need the limit. Let's remove the limit and run this again. Hopefully we should see several, but we just have one, and it is the SIR is the short name, Staten Island Railway. That's the route 2, and that's probably what is right here. And if we look at where it starts, between St. George and Tottenville terminals. At the St. George terminals, customers can make connections with the Staten Island ferry service. All right, so that makes it clear that the ferry, if you want to go to Staten Island, you are essentially what you are doing is you want to take a ferry to the St. George station, and then from there you can take the train all the way up to this Tottenville. I'm hoping I'm pronouncing it correctly. And that's how this is connected. So between these two parts, there's ferry is the option that one would have to choose. All right, so that's awesome. Now we know what exactly each of these column means. We know what route ID is, short names are, route type is, and that's how I'll go about exploring the data set before beginning the actual work. And if you have a data set that probably if you are working in a company, you'll have a data set that you may have to discuss with your team or clients to sort of understand what each of the columns mean, what data it is referring to, how the data was created. For now, in this New York subway, it's relatively easier. We have a nice map for us to look at, and that's helping us understand the data. Let's keep going, and now what we'll do is look at station complexes. And we created another tab. Again, what I'll do is just put the path to the table right here and go back and just copy this line of code, put it here, and again change the path from this. We remove that and put this, and here of course we don't need the route type, we just need that. When we run this, we should see the table come up. We have station complexes, so we have the complex ID and the complex name. Let's say Canal Street, if we have anything for that. And to do that, what we would have to do is use a where statement. So what I'll do is copy paste the code here, then use the where statement just to see if we see that we get a complex ID for that, where complex underscore name is equal to Canal Street, and then we put a semicolon either right after that or right below this where, and run this. And we do have a number. We have a number which is 623, but that 623 is written nowhere on this map. So my guess is that is something we could use while accessing data from this particular table, complex ID. And because the complex ID could be matched with the complex ID in the station, and maybe that's the purpose of that ID. So for now, we'll just leave it at this and move on to the next table. The next table is station entrances. Before looking into station entrances, so let's see, station entrances. We have all of these, so we have plenty of information. We do have stations as well, right? So let's look at station entrances and see what we've got. So again, I'm copying the ID, creating a new tab, using the angled quotes, and down here again copy this, or simply we could write it select star from this and then limit 10, and that's what we have for the code. And here we have a lot many columns. As you can see, there are several columns. So let's try to look at one by one to each of them. Division, then we have the line, station name, Wall Street. So let's first look at the Wall Street station. Can we find it on the map? And then from there we'll start to explore what routes that particular station has, and based on that we'll start getting some ideas to the location and everything. Let me narrow down these columns so that they are easy to look at. Several of these are okay, and this a few more: north south street, east west street, corner. Then this is just the information on lat, longitude, etc. So the first one is Wall Street. If we go down here again, let's find out where Wall Street is. Wall Street, that's where Wall Street is, right here. So we have Wall Street, and if you look at the station, there are two Wall Streets. There's one Wall Street here. There's a second Wall Street that's right here. And I'm guessing that this 4.5, that's this Wall Street on the green line, and there's another Wall Street uh, on the 2.3. There are two different routes that go through Wall Street. And if we look at another map, and here again we have the Wall Street, we have the same two routes. Look at the other map, and again here we do see that there's just there's these two again the same route. So along that Wall Street we have probably more than one stations. Okay. IRT, so division is IRT. I'm trying to think what that means. There's nothing in here. Then line is Clark. C, does that refer to the letter C that we saw earlier? That's my question. The that's the, where is it? This one. We have 4, 5, and then we have 2, 3. Those are there. No, I'm not sure what this is referring to, Clark and the IRT. Maybe if we Google IRT Clark Metro Subway New York, if there is a Wikipedia page, maybe we'll. So there is a Clark Street station. All right, and let's find out what are the IRTs. IRT, Interborough Rapid Transit Company opened its first subway line. Okay, so that's the name of a company, division. Maybe this is the company that runs that trains on that route. And the line is Clark, so maybe Clark should be somewhere on this, because here we have a Wikipedia page for the Clark Street station. Let's search Clark. There it is, Clark Street. Okay, Clark Street station, and so that does connect with the Wall Street. As you can see, the red line, it does connect there. So this is the company name, that's a station name, that's the line, the line has that station name. And if we look here, these are the two subways, route 2 and 3, that go through Clark Station, and that's what we have. A station name is Wall Street. Then we have the Fulton Station. I'm guessing these are all in line. So yeah, Wall Street, Fulton, and so on. Latitude, longitude, that's good for plotting. And routes, what routes go through those stations, through this station. Wall Street is just route 2 and route 3. And that's what we saw. And this is route 2, route 3. Both of them go through the Clark Station and the Wall Street. Now, I'm thinking there is another Clark and Fulton, so that's what we go. That's also, that's the next station. But what we can try to find out is similar to the Clark. I'm guessing we should have another route that which is this one. The green line. That is the number 4. Maybe that has some other line name, and we can use the where statement to filter out the other rows. So we can say where station underscore name is equal to wall space st street, and we're not in for now. We'll just get all, or we can say distinct, and say distinct star. And why not limit this to 10, because I'm not sure how many rows we'll get. And now we can run this. Is the error station geometry cannot be used in select distinct, and that's fine. We just drop that. Look at the 10 rows we get, and as you can see, we got the Clark back again. And we have Lexington. So Lexington should be on the green line somewhere. And if we look at this, we have the green line that goes through here, through the Wall Street, and this, and then goes through here. Lexington. Let's search for that. Lexington. So here it is, Lexington Avenue. And there are 9 of these. So there's 1, 2, 3, 4. All right. Manhattan, Brooklyn. So this is nice information here. Okay, Lexington Avenue. That's what we have, and that's number 4 that goes through the Wall Street. All right, that explains that. And now we can put the distinct, remove the comments, remove the star. And now this time we'll get just 3 columns and hopefully a whole bunch of rows with Wall Street station name. And there are just 2, and that's accurate because through Wall Street there are just 2 lines going. There's the green line and there's the red line. So this green line goes through Lexington. If you come up here in Google and look for Lexington, it should be able, it'll take us to this Lexington Avenue line, and in this there is number 4, and that's exactly what we're looking at, number 4. Awesome. So all in all, what we have now from this table is we know what the division is referring to, then we know what the line is referring to. It's probably is the station, and the division is the looks like the company that is running that line. For Lexington, again, it's the same IRT. And apart from that, we also saw the routes that are there for each of these. So we have the different routes here. Total 11 routes are listed, but then these are null because there's just nothing to put there. There are only 2 routes for Wall Street Station. The rest are blank. And entrance type. This is interesting. So we have several different entrance types. Let's do a quick search for what types of entrances are there, and hopefully we'll see if there is that wheelchair access that we were looking at in the very earlier videos. The distinct, and we say entrance type, and for now we drop the where statement. We don't need that, and we do not need any limits because we want to see all types of entrance. So we have stair, easement, door, elevator, escalator, ramp, and a walkway. So these are their easement. Let me check what this is referring to. Easement is okay. Entrance type. Entrance type. Probably on Wikipedia. Any picture of this? No. I think it's probably what is referring to is a ramp. Maybe in images we'll see. Nope. Easement. All right. It's for now. Let's just think of it as a one way to way of entrance type. We have doors, elevators, escalators, ramp, and walkway. All of these are there. And next, what we can look at is what type of entrances are there for each of these stations. So if we go back to this, what we are looking at is the station entrances, and if we look at the station name and the entrance type, maybe we would be able to find out what stations have what. The station name, comma, entrance type, and hopefully we'll see that most of the stations have of course they'll have the stairs, and we could sort this. This is already sorted, looks like. So not all stations have all the types of entrance types. Other things in this table, before we move on, let's look at other items that we have in this table. The first one is we have the latitude, longitude, the routes, entrance types we looked at, staff. So full, none. So some stations probably don't have any staff, and we can try to find out if there are any other variations in there. And for that, what I can do is just copy that. We can copy and paste it here, and again we can leave the station name or we can remove it. Just add the staff. What we are interested in finding is how are there any different types there. My guess is there's full. Okay, there's full, there's part, and there's SP. This probably means special event. That's my thinking is, and there is none. So some stations do not have any staff. Probably the tickets there would be maybe some automated machines are there. And if you want to try to find out what which those stations are, you could simply say where staff is equal to none, and then put a distinct or just put a star there, and then run this, and this should give the stations that have uh, the stations that do not have any staff. And so these stations for here they say that there's no staff on these stations. Okay, all right. And in addition to this, then we have the routes as we saw before. And then we have north south street, east west street. So if we're trying to figure out where the location is on the map for this, so this is William Street and the Wall Street, and that is for the station Wall Street. If you go to the map and if we look at the station, here is Wall Street, but there's no roads written down there. Look at this map. Again, there are no names on the roads. Again, this map, there are no names on the road. So what we could do is we could go to Google Maps, and so Wall Street, New York, and here is the map. And on this map, we should be able to see uh, the exact street. So where is Wall Street? We have the New York Stock Exchange, and that's the Wall Street there. And so that's the Wall Street. It is going like this. And here is the station, the Wall Street subway station that we saw on the map. There is the second Wall Street subway station. So those are the two stations that we are talking about. And again, when we look at the names of the streets, so William Street is the north-south street that runs north-south. So again, we come back here and try to figure out where is the William Street. So that's the Broadway, and we go back here. So we have Wall Street, and then we have the South Street. So Wall Street ends on the South Street. But I'm still not sure where the William Street is. So there's the front, Water Street, Wall Street, Beaver Street, Hanover Street, William Street, right here. So that's the William Street. Okay, I should have looked here. So this is the intersection of William Street and Wall Street. That's where the station is, and then the second Wall Street station. That's at the intersection of William Street and Pine Street. So that's one, and then that's where the second one is. I think it was up here. So right here, there's the second one. And I'm wondering where the Pine Street is. This is the intersection of Broadway and the Wall Street. Maybe there's some street right there. Pine Street. don't see it here. New Street, New Street. Then we have the Broad Street. All right. Okay, keep going. Wall Street. I don't see Pine Street. Pine Street. We could do a search and type pine instead of wall, and it should be somewhere Pine Street. That's the Pine Street. And let's walk down the street all the way here, and so that's one block up. So this is where we were. The station is located right here, and this is saying East West Street. East West Street. So that's the William and Pine Street. East West. So again we go back here. William and Pine. Right. Okay, let's keep looking. That's the Pine Street. Where did the station go? Right here. The Pine Street. That's what is going east west. The east west. This is north south. So this is east west and this is north south. Maybe that's what this is referring to on for this station. That's the intersection of William Street and Wall Street, and then the east-west road over there is this one, the Pine Street. That's right here. Right. So we have that information, and then there's something else. Free crossover. Free crossover. Thinking that means maybe you could change the routes. So New York subway free crossover. Let's. What is free crossover? And there is nothing up here. Subway free crossover. There's nothing here, so I'm just going to search for free crossover. And there's several other things here. Okay. So for now, what we'll do is we'll just free crossover in subway New York. Okay, I think that's what it means. A crossover means if you are on Route 2, you could move into Route 4 if you want to change the trains. That's what I'm thinking. Okay, and then we have entry, exit. Wondering why we have false for exit. Exit only. Entry is there, but there's no entry for these. So what are those? We have the Fulton Street. Yeah, so not entirely sure what these are referring to. Vending. So again, not sure what this vending is referring to. Is it the tickets that you can purchase from vending machine, or like the automated machine that you can punch in the your destination station and it will give you the tickets? Maybe that's what it is. If I find the description of all these columns, I'll put them. I'll discuss them in the video. But for now, we're just browsing through these tables, and then we have the station geometry, entrance geometry, etc. So that's the location. All right, and so far we looked at 1, 2, 3 stations, 4 tables. We'll now look at the stations table. Again, I'm going to copy this and create a new tab. And this is, I might edit some of the recording that I have because it's probably is getting too long. The reason why I'm putting all this here is because in reality, when you're working on a project, let's say SQL project, that this could be one of the ways you may be proceeding, uh, and the reason for that is you definitely want to understand what the data set is, how it was created, or what each of the columns in the data set mean. And that's what we are trying to do. We are looking at the subway data set and trying to understand what those columns are trying to tell us. Okay, subway, there's the stations. I'm missing the S. Just put the S there and run this now. And in here, we should expect all these columns. So latitude, longitude, all right. Borough name, that what we already saw. We have the daytime routes, the structure. This would be interesting. Not one, just wondering what that means. Then we have the line division, stop ID, complex ID that we already seen. So let's look at this. We have the complex ID, GFT, GTFS stop ID. And what would that? So reference static transit GTFS stop ID, the New York subway, and it doesn't say anything. GTFS. Let's look in Wikipedia if there is anything. There's nothing there. So here is the GTFS and real-time specification. Real-time reference for the New York subway. What is GTFS? And it doesn't say what it is. All right, let's get back to the table. Then we have the stop ID for that. We have the division. Then we have the line, station name, which we already saw. We have the borough name, daytime routes, NW, NQRW, and those I think are referring to the the names that we just saw earlier in one of these maps. So if we zoom out, scroll up, and here N, where is N, W, R, and so on. So those are just the route names, and they are comma separate, not comma space separated in here. Daytime routes, structure elevated. I'm guessing that's on sort of bridge level. We have subway. This would be underground. North direction level. That's the probably the intersection of these two, Astoria and Ditmars Boulevard, station latitude, longitude, and so on. So this table mostly has the IDs, borough names, and the structure type. So maybe the structure type is something that we might be able to use from this table. In this table, we'll look at the stop times and what this particular table has. Stop underscore time. So what I'll do is just copy this and put this in yet another tab, and then change the name stations to stop. So change this to stop underscore times with a S, and run this entire query. And out here we have stop times. Wonder where we have that. Right here. This is the stop times. Okay. So for stop times, we have the trip ID. And trip ID has plenty of information. I'm not sure what each of these means, but as we look through the dataset, we may be able to find out. One thing for sure we can see is the day. This is Sunday. And the rest, I'm not sure at the moment. Arrival time, that's 000. Departure time, 000. Stop ID is S01S, and this stop ID we may be able to connect that stop ID to the stop ID that we just saw in the earlier table, which was which table? Which was this stations table. If you look in the stations table, we do have a GTFS stop ID, and my guess is that stop ID and this stop ID might we might be able to join them somehow. If we will have to see, because maybe this part of the string is available in that string. So in trip ID, as you can see in trip ID, so this is stop ID is S01S, and here we have S01, but it's not S, it's an R. Again, we have the M11S, but we do not have the rest. Right, we do have the L, but we don't have the rest. So what if we copy this? I'm wondering if this dotted line, dotted uh, string that we have, if it will give any additional hidden details. It doesn't. So that is the string how it is laid out. Those dots are there. I mean, the string is incomplete. So we may not be able to use that part of the string. Stop sequence 1, then we have stop head sign, and then we have the pickup type, drop off type. I'm not sure what all of these are referring to. And shape, distance traveled here. So stop sequence may be useful. We can try and find out how many stop sequences are there. And so all we need to do is just say stop underscore sequence, and I take a distinct on this, distinct stop sequence, and then run just this query, see what we get. So there are 10 different types of stop sequences. So maybe it is, looks like it is something important, but we will have to find some information on what those numbers are referring to. Stop head sign, these are all null, but we could always look at what those head signs unique values are there. Stop head sign, and then just run these 3 lines of code, and all of them are null. So well, that makes it easy. We don't care about that column, we just simply ignore it. And pickup type, drop off type, these again are zeros. Let's look at pickup type and drop off type. So pickup type, and run this. And so we have 2 different pickup types, and then let's look at drop off, and hopefully this also has 1 or 2 values. Yeah, this also has 2 values. So that's what we have in the stop times table. Let's look at this final 2. One of them is the subway ridership, and this is going to be an interesting table because it only has the number of people who travel. So if we go back to this page, add the angled quotation marks before and after, then you select star from this table, and you can limit this to 10 and run this. As we have here, we have these numbers starting from year 2013 to 2018, and then we have the changes raw percent. Again, we do not know if this change is based on 2017 or 2013. That we'll have to find out. We have the routes and station name. So that's a straightforward table. We have the routes, station name, and on this, if we look at the station name Wall Street, we should be able to see just 2 routes. Let's copy paste that here and just say where station underscore name is equal to Wall Street. Now run this. We should be able to see just the two routes that we saw earlier. So we have 2 comma 3 and well, looks like we have 4 comma 5. There are 4 routes that go through this station, not just 2. And these are the ridership counts. And the last column that we have in this table is rank ridership. So rank ridership is 50 to 70. Again, we do not know at this moment what those are, and we'll have to find what it means. The last table is trips, and we can create yet another new tab. Type select star from angled single quotes, closing angled single quotes, limit of 10, semicolon, and then run. And down here we have the output, route ID, service ID, trip ID, and so service ID, the first part is the same here for trip ID. Trip ID has some additional part of the string. I think maybe service ID is used to calculate the trip ID, create the trip ID. Trip head sign, direction, block ID, and the shape ID. Again, shape ID, not sure what this is, but it's part of the trip ID. And this is, I'm not sure what this number is. So again, we'll have to, if we can, we'll try to find out what that particular, those numbers mean. So that's how, that was the last table, and that's how we can explore the data set. And if you are working on a project, you are given a data set. This was in real time, and still I've done some edits. Still, this is pretty long video, and the reason for doing that is to give you an idea of how much time you end up putting in understanding the data set. And still you have several unanswered questions. You may have some unanswered questions, just as we have here. And should you proceed without all information on the table? It depends on the question that you're trying to ask. In this case, I'll try to try to understand what all the data is, and also try to find out additional information if I can on the metro transit. So what each of these, if we get some description metadata for exact these tables, then that would be fantastic. If not, we'll have to go with some assumptions. Right, so that was it for this video. I hope in this video you got an idea about how to go about exploring the data set, trying to understand what is where, what things are kept where in which tables, so that you can then start pulling data to when you are trying to answer questions. And you may have realized that this is a slow process, and it takes time, but this is a one-time time investment once you know the data set. And if that's the only data set you are going to use, then you'll know what is where, and won't have to spend time to search for the columns in different tables once you know them. Of course, if you have new tables coming up every day, then you'll have to keep up with that information as well. So thank you. I hope this was useful. If you have any comments or suggestions, please do let me know in the comment section below. In the next video, we'll start writing queries to answer some simple questions, and we'll go from there. Meanwhile, if you have any questions, comments, please do post them in the comment section below. Thank you.